Hi, everyone. I'm back with the next chapter of Awareness Through Movement by Moshe Feldenkrais. Once again, I urge you to get your own copy of this book, but I'm trying to make it easy for you, so I'm just reading you the book, and I'm also doing commentaries. So what's kind of happening at this point is it's pretty simple to read, and so I'll get this video out, and then it'll probably be a few more days before I get to the commentary. But you probably know by now there's a whole series, so I hope you've found the playlist. If you're driving somewhere or you're folding your laundry, listen to Awareness Through Movement by Moshe Feldenkrais. So anyway, let's get back into the next chapter. It's called Structure and Function. And as always, there's these little subheadings that are going on. And so you'll hear me read subheadings from time to time. And here we go. Abstraction is exclusively human. We have said that the whole life process can be broken down into 4 components: movement, sensing, feeling, and thought. The last element is different in most aspects from movement. We may perhaps accept the view that thought, in the form in which it is found in man, is specific to him. While some sparks of something similar to thought may admittedly be observed in the higher animals, there is no doubt that abstraction remains the exclusive province of man. The harmonic theory in music, space geometry, the theory of groups or probability are unimaginable outside of man's own mind. The human brain and nervous system also have a structural peculiarity in one part that is essentially different from the structures in other parts of the brain that are on the whole similar to those possessed by other living creatures. There is no space here for a detailed analysis of the anatomical and physiological differences, and a general description of its structure will have to suffice. The strictly individual part of the brain. The brain requires a certain chemical environment and a certain temperature for subsistence. And every living body contains a group of structures that direct and regulate the chemistry and heat of the whole in such a way that it may survive. This group of structures is the Reinach system. It supplies the individual internal requirements of every living organism. If these structures were faulty, the whole organism will be crippled or not viable at all. These structures are symmetrical and are inherited in every detail of arrangement and functioning. Internal periodic drives. A second group of structures in the brain deal with everything that concerns the outward expression of vital internal needs. The need to sustain the body and the Reinach system creates internal drives that express themselves towards the environment. This is done by the limbic system, a group of structures that deal with everything concerning the individual's movements in the field of gravity and the satisfaction of all internal drives, such as hunger and thirst and the elimination of waste products. In short, it deals with all internal needs that intensify when not satisfied, but that are reduced or abated when satisfied, until the need increases and the cycle starts again. All the marvels that we usually call instinct, such as the building of nests by birds, the spider's web, and the ability of the bee and the pigeon to find their way home over great distances, originate in these structures. The dawn of the ability to learn. In activities of this kind, the specific properties of the human nervous system are already noticeable. The structure, organization, and actions are mainly inherited, by contrast with the Reinach system described above, which is entirely inherited and remains unchanged from individual to individual, except in cases of basic evolutionary changes. Instincts are not as stationary and definite as we often think. They vary, and there are small instinctual differences between individuals. In some cases, the instinct is weak, and a certain amount of individual experience is needed for action to proceed, as where, for instance, a newborn child fails to suck until its lips are stimulated with the nipple. In some cases, instinct permits a fair degree of adjustment to circumstances, and the first hint of ability to change with a changing environment is found. In short, the birth or dawn of the ability to learn. Thus, for instance, birds accustom themselves to building nests of new materials when they are moved to strange surroundings. But the adjustment is difficult, and not all individuals succeed equally well. Some do not manage to adjust at all. The adjustment of instincts to the demands of new surroundings may go so far as to approach what we are accustomed to call understanding and learning. Fine differentiation is a human prerogative. A third group of structures of the brain is concerned with activities that distinguish man from animals. This is the supralimbic system, which is much more highly developed in man than in any of the higher animals. It is this system that assures the delicate differentiation of the muscles of the hand, thereby multiplying the possible number of patterns, rhythms, and shades of any operation. This system turns the human hand into an instrument capable of playing music, drawing, writing, or doing many other activities. The supralimbic system imparts an equal sensitivity to the muscles of the mouth, throat, and breathing apparatus. Similarly, here, the power of differentiation multiplies the number of different sound patterns that it is possible to produce, resulting in the creation of hundreds of languages and a great variety of ways of singing and whistling. Individual experience versus heredity. The structure and tissues of this nerve system are inherited, but their function depends largely on individual experience. No two handwritings are alike. An individual's handwriting will depend on the language he first learned to write, the kind of writing he was taught, the pen or other instrument he used, the position taken up while writing, and so on. That is, it will depend on everything that affected the formations of patterns or codes in the motor cortex of the brain while learning. The proper pronunciation of an individual's mother tongue largely determines the development of the muscles of his tongue, mouth, voice, and his palate. A man's first language will affect the relative strength of the muscles of his mouth and the structures of the cavity to such an extent that in any subsequent language spoken, it will be possible to recognize what language the person spoke before, owing to the difficulty of adjusting the organs of speech to the new inflections. Here, the individual's personal experience actually becomes a factor that determines the structural development no less than the hereditary factors themselves. This is a unique peculiarity. The concept of opposites derives from structure. The activity in the third system is asymmetrical. The right side differs from the left side, as opposed to the symmetry that is the rule in the other two systems. The asymmetry is behind the differentiation of right and left. When the right hand is dominant, the speech center forms on the left side of the brain and inversely. It is assumed that this primary opposition between right and left is the basis of our concept of opposites in general. As the right hand is usually the more functional one, in many languages the word right also carries such meanings as correct, law, a claim to do something, and authority. For example, Note the English right, the Russian bravo, the German recht, and the French droit. Sorry if the German or Russian was poorly pronounced. I'm pretty sure it was, but anyways, moving on. Primitive modes of thought tend to oppose good to bad, black to white, cold to hot, light to dark, and to see them in opposition or conflict. More developed thinking can hardly attribute opposition to them in any real sense. Dark and cold, for instance, are by no means the opposites of light and heat. Where there is no light, it is dark, and the relationship between heat and cold is even more complicated.